Hello, this is a demo video for the usage of the tool Aerialist. Before going through this video, you need to have the environment set up as detailed in the documentation on GitHub. After that, you can use the command line interface in a few different scenarios that we will show today. The first one is running some manual flight test. This means commands that are coming from a remote control. The first test, we are using the local agent, meaning that we are running the tests in the simulation on our local machine. This way we can have direct access to the simulator and see the drone while flying. After executing the command line, we will see the simulation environment being set up. We will see the gazebo window showing up. Then the drone, the commands are being scheduled to send to the drone. The drone takes off and maneuvers in different directions and then lands. After the test finishes, we will have the flight log and the flight trajectory plotted in our results folder. The next test that we will run is a mission or autonomous flight. This time we are using some predefined missions, and then we are putting some obstacles on the map. The goal is to here to test the obstacle avoidance feature of PX4. At the moment, we are using the Docker agent. This means running the test cases locally, but inside the Docker container. When you run the command, you will see a Docker container being initialized on your local setup. And then the test is being executed and simulated inside that Docker container on your machine. Using the Docker usage lets us run the test cases on our local machine without needing to install every dependencies like PX4 avoidance and everything. This is the best and recommended way for beginners to use the tool. Next test case that we will show is running the exact same test case, the autonomous flight, this time in the Kubernetes cluster. So as before, we are running 5 times in parallel the same test case, and it's been translated into Kubernetes job with 5 executions, and the files are being shared over a Nextcloud instance. So when we run the command line, we will see the files copied to the Nextcloud, then shared with the new Kubernetes job what we have. You see 5 parallel pods are running, each of them running a separate simulation. And the same commands that the same behavior that we could see before in the Docker execution is happening this time in the cloud. Then when the tests are finished, the flight logs will be copied by the simulation containers to the same folder. All of them are downloaded and then plotted here. As you see, there are a couple of differences in each runs. That's why Kubernetes is a good way to test when we have tests that have varied trajectory over different runs. Thank you. For the latest documentation and examples, check the GitHub repository.